Today we are going to see derivatives of inverse function. We have a question, that is y is equal to sine inverse of x square minus 1. So for y is equal to sine inverse x, its derivative is 1 upon root of 1 minus x square. So basically for this question, its derivative will be given by dy by dx is equal to 1 upon under root of 1 minus x square, that is x square minus 1 whole square, into the derivative of x square minus 1. In the next step, it will be 1 upon under root of 1 minus x square minus 1 whole square. It will be x raised to 4 minus 2x square plus 1 into derivative of x square will be 2x and derivative of 1 will be 0. So it will be 2x upon under root of 1 minus x raised to 4 plus 2x square minus 1. In the next step, 1 minus 1 will be 0. The remaining term will be 2x square plus x raised to 4. So we will take x as a common from the denominator. In denominator, it will remain as 2 plus x square. X to x will get cancelled from numerator and denominator. Sorry, over here it will be 2x square minus x raised to 4, 2 minus x square. So it will remain as 2 upon under root of 2 minus x square. It will be our final solution to the problem. So let us take next example. We have another example on cos inverse. So we will see each and every example of each and every type of inverse function. So we have a next example, that is y is equal to cos inverse of under root of cos x. So the function is of the type y is equal to cos inverse x. For this type of example, we have its derivative given by dy by dx is equal to minus 1 upon under root of 1 minus x square. So over here, uh, we will use the same formula, that is dy y is equal to for cos inverse x, dy by dx is equal to minus 1 upon under root of 1 minus x square. So dy by dx, differentiating with respect to x, dy by dx 1 upon under root of 1 minus x square minus 1 upon under root of 1 minus x square, that is under root of cos x whole bracket square into derivative of under root of cos x. So in the next step, it will be minus 1 upon under root of 1 minus under root of cos x square will be cos x into derivative of under root of cos x will be 1 upon 2 root of cos x into derivative of cos x. So in the next step, 1 minus under root of 1 minus cos x into 1 upon 2 root of cos x into derivative of cos x will be minus sin x. So in the next step, it will become minus minus will get converted into positive sign. So remaining term will be sin x upon 2 under root of cos x into under root of 1 minus cos x, which can be written as sin x upon 2 into under root of cos x into 1 minus cos x. So we have got a final solution to our problem. So this was another type of the problem using a cos inverse function. Now next problem will be a y is equal to tan inverse x. For y is equal to tan inverse x, y is equal to tan inverse x. Basically, we will use for tan inverse x, the derivative is given as, how its derivative is given as, we very well know. We will use y is equal to tan inverse of 1 plus 2x plus tan inverse of 1 minus 2x. We very well know for tan inverse functions, the formula, that is tan plus tan is 1 plus tan plus tan upon 1 minus tan into tan. Basically this will be the formula. So for this example, we are going to use a formula that is that it will be. So let us use our basic formula for tan inverse, that is y is equal to tan inverse of tan inverse of 1 plus 2x plus 1 minus 2x upon 1 minus 1 plus 2x into 1 minus 2x. So in the next step it will become tan inverse of 1 plus 1 will become 2, whereas 2x minus 2x will get cancelled. In the denominator it will remain as 1 minus 4x square. So in the next step it will be tan inverse of 2 upon 1 minus 1 will become 0, minus minus will become plus, so it will be 4x square. So in the denominator tan inverse of 1 upon 2x square, for 2 will get cancelled, it will remain as 2x square. So we know uh, we will convert it into the form of cot inverse of 2x square, because inverse of tan is a cot. So in the next step we have to find out its derivative. Dy by dx is equal to cot inverse of 2x square. For cot inverse of 2x square we have a derivative of cot inverse x, that is derivative of if y is cot inverse of x, then its derivative is given as dy by dx is equal to minus 1 upon 1 plus x square. So over here our function is cot inverse of 2x square, so dy by dx is equal to minus 1 upon 1 plus x square, over here is 2x square whole square, into derivative of 2x square, that is derivative of 2x square. So it will be minus 1 upon 1 plus 4 x raised to 4 into derivative of 2x square will be 2 as it is, derivative of x square will be 2x. So our final term will be minus 4x upon 1 plus 4x raised to 4. So this is our final solution to the problem. So we will see the next problem. Y is equal to cot inverse of y is equal to cot inverse of 1 minus cos 2x upon 1 minus cos 2x upon sin 2x. Have you taken it down? Next problem. So let us see our next problem, that is y is equal to cot inverse of 1 minus cos 2x upon sin 2x. So basically over here we very well know for cos 2x the formula is cos square x minus sin square x. Again for sin 2x it is given as 2 sin x into cos x, and for sin square x plus cos square x is equal to 1. So we will make use of this formulas over here into this example. So y is equal to cot inverse of sine for 1 it will we will write it as sin square x plus cos square x minus sin square x for sin cos 2x. In the denominator we will write for sin 2x it will be 2 sin x into cos x. So y is equal to cot inverse of sin square x plus cos square x minus cos square x, minus minus will become plus, so plus sin square x upon 2 sin x into cos x. So sin square x, so cos square x will get cancelled, the remaining term will be cot inverse of y is equal to cot inverse of sin square x plus sin square x, it will be 2 sin square of x divided by 2 sin x into cos x. So it will be cot inverse of 2 sin square x sin 1 sin in and 2 sin x, and from the numerator, and 2 sin x from the denominator will get cancelled. So the remaining term will be sin x upon cos x. So it will be cot inverse of y is equal to cot inverse of tan x. So but we know that tan of pi by 2 minus theta, it is cot theta. So we will make use of this formula, that is cot inverse of cot of pi by 2 minus x, it will be tan x. So cot inverse and cot will get cancelled, the remaining term will be pi by 2 minus x. So y is equal to pi by 2 minus x. We have to find out its derivative, dy by dx. That is d by dx of pi by 2 minus x. It will come out as derivative of pi by 2 is 0, whereas derivative of x will be minus 1. So the final answer is dy by dx is equal to minus 1. So this was our solution to the problem. So now let us move to the next problem. The next problem is y is equal to sine inverse of y is equal to sine inverse of 1 minus x. Y is equal to sine inverse of 1 minus x upon 1 plus x. Have you taken down problem? Take down next problem. y is equal to y is equal to y is equal to very simple examples are there. Y is equal to sine inverse of 1 minus x upon 1 plus x. So over here we are going to make use of some substitutions. Using this substitution, it will be easier for us to solve such kinds of problem. So our problem is y is equal to sine inverse of 1 minus x upon 1 plus x. So what substitution can we make use of? So put x is equal to tan square theta. So theta will be tan inverse of under root x. So we have to take under root on both sides. So it will remain as theta is equal to tan inverse of under root x. So y is equal to sine inverse of 1 minus x. So for x, we are already going to put a substitution, that is tan square theta. 1 minus tan square theta upon 1 plus tan square theta. But we know that how we can write this tan square theta and sine square theta, how we can write it as so as that our final solution will come out. So it can be written very easily, that is sine square tan square theta is sine square theta upon cos square theta, whereas 1 can be written as cos square theta upon cos square theta. So it will remain as cos square theta minus sine square theta upon cos square theta divided by cos square theta plus sine square theta upon cos square theta. Cos square theta will get cancelled. So remaining term will be and so cos square theta plus sine square theta will be 1, and remaining term will be cos square theta minus sine square theta, which will be cos 2 theta. We will make it use of it. So it will be cos square theta minus sine square theta. But we very well know that cos square theta minus sine square theta is cos 2 theta. So sine inverse of cos 2 theta. So it will be sine inverse of cos 2 theta can be written as, in terms of sine theta, sine of pi by 2 minus 2 theta. So it will come out as sine inverse and sine will get cancelled. The remaining term will be pi by 2 minus 2 theta. Pi by 2 minus 2 theta. But for 2 theta, we have already found out its value, that is 2 tan inverse of under root x. So we have to find out the derivative of the term, that is pi by 2 minus 2 tan inverse of under root x. 2 tan inverse of under root x. So dy by dx, differentiating with respect to x. derivative of pi by 2 is 0. Minus 2 as it is. Derivative of tan inverse of under root x. What is the derivative of tan inverse of under root of x? 1 upon 1 plus x square, that is under root x square, into derivative of dy by dx of under root x. So it will come out as minus 2 upon under root of, it will 1 plus x into derivative of under root x will be 1 upon 2 root x. 1 upon 2 root x. So it will be minus 2 and 2 will get cancelled to each other. Remaining term will be minus 1 upon under root x into 1 plus x. It will be our final solution to the problem. So let us see another problem. Y is equal to cos inverse of y is equal to cos inverse of y is equal to cos inverse of under root of 1 plus x square. Y is equal to cos inverse of under root of 1 plus x square upon 2. So problem is y is equal to cos inverse of under root of 1 plus x square upon 2. So over here we are going to make a substitution as put x square is equal to cos 2 theta, and theta's value will be cos inverse of cos in 1 by 2 cos inverse of under root x square, or cos inverse of theta's value will be cos inverse of x square. So it will be in the next step y is equal to cos inverse of under root of 1 plus cos 2 theta upon 2 is equal to cos inverse of, so for 1 we can write it as, 1 can be expressed as sin square theta plus cos square theta, whereas cos 2 theta can be expressed as cos square theta minus sin square theta. So it can be written as y is equal to cos inverse of under root of sin square theta plus cos square theta plus cos square theta minus sin square theta divided by 2. So sin square theta will get cancelled. Cos square theta plus cos square theta will be 2 cos square theta. So it will be cos inverse of under root of 2 cos square of theta. So it will be cos inverse of, it will be cos inverse of, in the next step it will be cos inverse of, so denominator we are having 2, 2 get cancelled, it will remain as under root of cos square theta cos inverse of cos theta, it will be y is equal to theta, but theta's value we have already found out as y theta will be given as 1 by 2 cos inverse of x square. So let us find out its derivative. Its derivative will be dy by dx, cos inverse derivative 1 by 2 as it is, derivative of cos inverse is minus 1 upon under root of 1 minus x square, that is x raised to 4, into derivative of x square will be 2x. So in the next step it will be 2 will get cancelled, it will remain as minus x upon under root of 1 minus x raised to 4, 1 minus x raised to 4. So let us see next example. y is equal to tan inverse of y is equal to tan inverse of Have you understood? Let us see next example. Y is equal to tan inverse of under root of 1 plus x square minus x. So over here we are going to make use of substitution. Put x is equal to tan theta. So it will be y is equal to tan inverse of under root of 1 plus tan square. So theta will be tan inverse of x. Theta will be tan inverse of x. So it will be 1 plus tan square theta minus tan theta. In the next step, it will be tan inverse of under root of 1 plus tan square theta will be sec square theta minus tan theta. In the next step, sec square theta. Sec square theta can be expressed as how we can express it as, so under root of tan inverse of, so under root of sec square theta will be sec theta minus tan theta. So in the next step it can be written as tan inverse of 1 upon cos theta minus sin theta upon cos theta. In the next step it will come out as tan inverse of 1 minus sin theta upon cos theta. The base will be the same. Base will be the same. So in the next step we will get finally y is equal to tan inverse of 1 minus cos of pi by 2 minus theta on sin pi by 2 minus theta. So it will be tan inverse of 2 sin square of pi by 2 minus theta by 2 divided by 2 sin of pi by 4 minus theta by 2 into cos of pi by 4 minus theta by 2. Y is equal to tan inverse of tan pi by 4 minus theta by 2. So in the next step it will be pi by 4 minus theta by 2. But already theta we have found out as tan inverse of x divided by 2. So dy by dx it will be minus 1 by 2. Tan inverse of x will be 1 upon 1 plus x square. So final answer we will get it as minus 1 upon 2 into 1 plus x square. So this was the solution to our problem. Thank you. We will solve more number of examples of another type in the next lecture. Thank you.